So I am a security solutions architect. I work in the security space, a slightly different viewpoint on things than the typical SRE. But there's a lot of overlap between the two. But I want to talk about supply chain attacks. So if you want to follow along with the slides, the URL down there in the corner is live. You can use that to download the PDF of the talk and click on some of the links as we go through. But well, at least it's not a QR code, right? So
Any links ever.
Never click any links ever. Yes. Well, you're going to type it in, so that's even better. This is some facts from the open source State of Open Source report and the State of Enterprise Open Source report from Red Hat 2022, which basically, you know, as we all know, lots and lots of the software that we use is dependent on open source software. And interestingly, nearly 90% of IT leaders are using open source because they believe that it has greater security than proprietary software. So I think they get that notion because they're hoping that there are a lot more eyes on open source software than there is on proprietary software. I'm hoping to dissuade you from this is that those eyeballs are applied unevenly throughout the software supply chain. So, you know, as background, tooling for hackers has pretty much, well, we've managed to develop tooling that helps protect kind of the front door. So the attackers are going in through the back door, through security supply chains. This also helps just in terms of the way that their effectiveness. So if they go through the front door, if they try to convince users and so forth, they have to convince lots of users all at once. And so that's a more difficult problem. If they can go to the source of the software, they only have to find one bug, and then that can apply to lots of people all at once by applying it to the software supply chain. So they've really started to think about this. And both your advanced persistent threats and your more ransomware crews, your more opportunistic types of attackers and threats. So the rate of malware in open source software is going up, just the same as the usage is. And so what we've seen is I think Gartner's take on this, that most organizations, or nearly 50% of organizations, will see a supply chain attack. I think that's probably an underestimate just because of the fact that if you can get into the open source supply chain, you have very broad coverage for where your attack is going to take place. So if you read, there's a specification called SALSA, Software Levels for Supply Chain Security. They propose that there's, you know, they identify many supply chain hacks. I'm going to propose that your supply chain is bigger than you think. Obviously, the code that you write is part of your attack surface. But at the same time, so are the libraries that are included in there. And this is the obvious parts of your software supply chain. Your test code, the unit tests that you write, have an effect on, are part of your software supply chain. They help you improve the reliability of your code, but they are also part of the attack surface. So are the frameworks, the test frameworks that you're using. So if you're using JUnit or using NPM unit or whatever, that's part of your attack surface. Your production application running on your production systems is part of your software supply chain system. So in particular, the production host infrastructure brings a different set of software than the software that you built and deployed. And so that adds to your, you know, your production supply chain. It doesn't stop there. The developers' laptops, they're part of your software supply chain. So we've seen attacks that come through by targeting the developers. The SRE or the admin laptops are also part of this. We've seen attacks that come through this area, admins. Your CI/CD pipeline is part of this in the OS that it resides on, right? So my talk at SREcon in San Mateo, in San Francisco earlier this year was about the risks that your CI/CD pipeline poses to your infrastructure and your software delivery mechanisms and all in between. Also your code repo system. So whatever repository system that you're using contains bugs and increases your software supply chain attack surface. All of the third-party apps that you run that support your product, both from things like email and other sorts of business applications that you run throughout your organization, they all provide a way to get in. For that matter, not just as attack vectors, but also for reliability. The talk in the previous session was about how their SaaS supplier went out of business with minimal notice. I think it was basically day of. They shut down a key service. This is both a reliability problem, their service was going to stop working, and secondly, becomes a supply chain issue in that now there's nobody managing those domains, and so now somebody can repurpose the DNS records, and now you've got all kinds of problems for that, as well as, well, the way cloud infrastructure is deployed, somebody could build cloud infrastructure that would cover that. So those third-party apps are part of your supply chain. Your browser ecosystem. Almost every piece of software you run today has a browser interface of some sort, and that browser ecosystem is part of your software supply chain. So whatever browsers you're running in your organization presents a really interesting attack surface to your malicious attackers. The workers in your organization, there's a human factors threat in here as well, and not just the end users in your organization that everybody likes to complain about, but your dev and your DevOps people are also a point of attack, and your sysadmins, your IT workers, the people that run the core, you guys are also a point of attack. Us guys, I guess. So this is the point I want to make, is your software supply chain is bigger than you think. And so let me, we can start with the obvious spot. As I talked about, the code, this is the code that you write. And your developers, your coders can make really silly mistakes here. There's a lot of tooling to help you do this, but hard-coded passwords are, we still write them today. Cisco, world's leading supplier of hard-coded passwords, still produces systems that have, hard-coded passwords in them. Other sorts of flaws, just SQL injections. So VMware, this year, another SQL injection flaw. And VMware, you're writing infrastructure code to build resilient virtual machines, resilient virtual infrastructure, and they're still adding flaws into their releases. Same way with, Fortinet, which is a security tool, and yet they're still making mistakes where unauthenticated remote code execution on a box. So in this stuff, these kinds of flaws can easily be detected through static security testing tools. So tools like SemGrep open source, SonarQube has open source. So it's easy to get at these things. And knowing what to look for, like there's plenty of documentation around this. This is the starting point. It is nowhere near the ending point of what you need to do. So the libraries that you include in your code. So these are some of the things. So log4shell, which is the log4j library, which 3-4 years ago, 2021, we're still, so my company builds vulnerability analysis tools that you run on servers. We still regularly find the versions, the vulnerable versions of log4j on our client's infrastructure. This happens all the time across our tooling. And it surprises me that after 3 years of knowing this, that people still haven't completely patched their systems and continue to deploy systems that still have these kinds of problems in them. Left pad. So left pad is more of a denial of service bug, but the owner of left pad, which was built into and a dependency of many NPM libraries that were delivered with Node.js, which is a common infrastructure. You see this all over the place. Just decided one day, yeah, no more left pad. I'm protesting something, and it's gone. So now you can't build, and you're stuck with not being able to build your system. And there are lots of these little tiny dependencies that exist in your environment. So if you are using Spring Boot, for example, just building the standard Spring Boot library, or building the standard default Spring Boot application with no additional fancy stuff, produces code that it relies on 151 separate libraries that come from different places, about 13 different organizations by count. That's a lot of trust you're putting into lots of organizations that are, not even arm's length away. Like, you've never talked to the guys that are doing the Jakarta framework. You haven't talked to the people who are doing the logging frameworks, the Log4Shell guys, or many of the other frameworks that are included by default in your Java applications. Same way with Node.js. There's just, bam, you're including just lots of different software from different sources. How can you check with this? Well, there are tools for doing vulnerability scanning. Some of them my company makes, but there are open source ones. NPM Audit is a tool that's freely available if you're using Node.js. OWASP, the OWASP project, which they do lots of great work. Their dependency checking tool does a great job of finding things in your library. Static code analyzers are important to run. Our VP of software security mandates that all of the code that we run comes from an internal curated library. So even though you're relying on and getting updates from many of these different libraries, we're pulling those in and running static analysis on those anyways, right? Theoretically, the people who built that software would have run static analyzers. But this gives you, when you do that, gives you a scope of a sense of how much you're really using in the environment. So, and you recognize that you've got, as you bring this into a separate library, you recognize the amount of toil and the amount of debt you're taking on for this. So it's a very useful thing to do. Building software bill of materials and creating the vulnerability exchange formats. So if you go to the online version of this talk and the ones that I'll submit to the website here, to the conference committee, at the end of that presentation will be a number of links to things that will show you how to experiment with these things, with building software bill of materials, building vulnerable exchange informations, and importing those same materials from your upstream vendors, your upstream dependencies. Very useful thing to do. The other thing to think about is, as you're building different applications in your system and for your customers, you need to make sure that you approve the SBOMs that you create. You want to look through those SBOMs and validate that they're actually fit for purpose. That's a lot of work, because if you're looking at 151 dependencies for just a basic Java application, that can be a lot. But there is overlap. If you're building a couple of different systems on the same foundation, most of those systems are going to use the same sets of dependencies. So you can identify those dependencies and approve them. But not every application is going to have the same specification, the same proof. So, for example, we have applications that do scanning from a user point of view, and then we have applications that we deliver to our customers that require elevated privileges. The application that uses elevated privileges has a much tighter control around the software bill of materials it's allowed to use, because we know that when we deliver this to customers, we've got to make sure that it doesn't compromise or in any way hinder their systems, and that system is running in a position of trust. All of our software runs in a position of trust, but those that run with elevated provisions more so. I said before, your test code and your test libraries are part of your library. And if you don't believe this, so who here has not heard of the XZUtils hack? That's kind of what I expected. Very few people. Yes. So, but XZUtils was an attempt to compromise one of the core libraries or put a backdoor in SSH via the test code. So the test code would run, and then the test code ran slightly differently when doing the deployment, and that slightly differently injected the backdoor into the software. So, you know, you think, oh, well, test code's just unit test. How does it doesn't change the code of the application? Well, it can, and there are ways to do it. And it, you know, for 2 years, the APT crew out of well, some nation state hacker attempted to inject code into here, and they got very, very close. Thankfully, there's some observability nerd in the world who was looking at performance of MySQL, and noticed, like, hey, these timings are really odd. So we caught that one just by chance. It's conceivable that that would have rolled out. Quite scary. And again, not where you'd look for it. You know, it's not in your dependencies, your library dependencies. It's in the test code. Do the same thing here that you do with your library. So use vulnerability checking, use a local curated response library for your unit tests, bring that code in, make sure it's fit for purpose, make sure you understand how it changes, and at the same time, recognize that you need to follow their updates. You can't just pull in the code this year and expect in 2028 to be building off that same library. It's probably going to have, first of all, bugs and you know, the contracts, the function calls will change and it won't work, but also there will have been security updates. You pull this into your library now, I guarantee you, in 3 months, there will be security updates to your testing library and to your running libraries, like, all the time. You know, the software you're building is getting updates every single day that are security related. Probably don't have to talk about production systems having bugs in them, but just as an example, you know, the software that we're running on those systems will have bugs, as well as all of the monitoring. So if you're putting you know, various monitoring tools, they also have bugs in them. But each one of these different bugs that I'm listing here were various kinds of remote code execution. In Struts, a remote code execution via a path traversal bug and a file upload. So you can upload a file, then come back to Struts and say, here, you know, browse this URL, and it turned out that what that did was cause Struts to run the code in the file that you just uploaded. So so PHP has had multitudes of these things where the Windows code page setting on different Windows systems causes the PHP interpreter to misinterpret the way that URLs are set to them, and then some of those options, some of those URLs are interpreted as parameters that run code that you can control, hence RCE. In Node.js, it's interesting, if you look this one up, it's not in the NVD yet. It is a placeholder. So it will be interesting to watch in a couple of weeks or a month or more to see what actually gets revealed in this last bug. I've looked around at some of the Node.js bug reports that have been going around. I think I know which particular issue this is, but it's still embargoed. But I have a feeling when it comes out, it's going to be interesting. So this happens all the time. So you've got to make sure you're up to date on all of these things. So if you had to, if you're building a system and Node.js is at your core, NPM is at your core, this is going to be a fire drill in a couple of weeks. Prepare for it now. Budget in your next sprint. I'm going to give half of our time to Node.js security fire drill. Just put that on your planning for the second half of November, and hopefully it won't come in the first half. Although the bug is there now, so if you, yeah. What do I recommend here? So your production systems need scanning for vulnerabilities. You need to patch those systems on a regular basis. Actually, we're at SREcon, so mostly you're going to be able to redeploy those systems with the current version of whatever Linux that you're pushing. So redeploy is the right way to approach this. Use file integrity monitoring to make sure that weird stuff isn't happening. Observability, of course, because systems that start running crypto miners look very different than your normal infrastructure or whatever else the hack might be. Endpoint detection is good if you can run endpoint detection. And then finally, you should be adopting for production immutable Linux instances. So there's absolutely no reason why your production OS should change underneath your production application, and figuring out how to build and deliver systems on immutable Linux systems is the right way to go. Also on immutable Windows systems, if you really want to tread that, sail that sea, it's possible. The Windows guys are, they're building minimal Windows systems, and they kind of get the concept. Yeah, your mileage will vary on Windows systems. Your CI/CD pipeline. So, like I said, the talk that I gave at the Americas conference was about CI/CD, and this was one of our examples. This Cloudflare was hacked, and it drove straight through their CI/CD pipeline. Was how the attackers were able to move laterally throughout the organization after they gained a very small toehold in the infrastructure. So it's a very interesting incident report, and what it tells you is that your CI/CD pipeline probably has lots of permissions, and there are ways to fake the CI/CD pipeline either as an internal malicious user or as an external person who gains a toehold of access. So your CI/CD pipeline often contains credentials to your infrastructure, and so yes, it's a scary part. You need a way to make sure that you know what's in your pipeline, that there's an assurance that people who modify the pipeline are the ones that are supposed to be doing so. Typically, the way that pipelines live in our infrastructure, they are in hidden files. What was it? .gitlab and .github/workflows, which are not normally seen by the code. This just steams my bacon. That some of the most important stuff in our repositories, the CI/CD stuff is given second shrift. So at least Jenkins has going for it is the fact that the CI/CD pipeline is called Jenkins file, which at least shows up as a real file when you ls the directory. It's part of your code. I contend to you that every system has two architectures. Whatever your production architecture, whatever your application architecture is, it has a second architecture, which is your build and deployment mechanism. And you have to think about those architectures at the same time. As you're building, as you're thinking about how you want to deploy and maintain your application, you need to think about your CI/CD architecture as well. When manufacturing people look at building a new product, whether you're a car manufacturer, an airplane manufacturer, a manufacturer of manufacturing tooling, whatever it is, you're going to design the product, and then you're going to design a factory to build that product. And those are pretty custom, pretty kind of fit for purpose. So If you go to a Ford factory that's building F-150 pickups and you decide tomorrow we're going to, build Tauruses there, it just doesn't work. The tooling that they've got is specific to that. Your CI/CD tooling is pretty specific to your to the application you're building, and it's in a position of trust, the same way that that application is in a position of trust. So treat it with the same care. Your code repo system. So we're all storing our code in something like something built off of the Git tooling, or SVN, or God knows, SCCS. Anybody remember SCCS from back in the day? Yeah, yay. All of us have gray hair. But each one of these has various RCEs. So that stash one is a SQL injection vulnerability. It comes from the sort parameter. That's bad. The Githia has various cross-site scripting bugs that have been introduced. Now, most of these, by the time they're actually released, are indeed fixed, but the next one is waiting for you. GitLab had a bug that allowed an attacker to trigger a pipeline as an arbitrary user. So again, this is a pipeline attack, a CI/CD attack. But these are all part and parcel of what you've got to deal with. For a code repo system, use somebody whose first job is building code repo systems, right? So if running a Git system is their main job, they better do it well. So I recommend that. If you're hosting it yourself, your mileage varies, because building and maintaining a CI/CD system is not job one. It's generally job 2 or 3 on the priority chart. It falls down in most organizations. That said, there are probably notable exceptions. Amazon has got some really great build tooling, but they also have a team where that's job 1. I imagine Netflix has got some guys that do some really great work, but there's a team where that's job 1, and that's probably not the case in most organizations, the smaller you are. And you've got to keep up to date with security updates, because the risks posed here, the unknown risks that will be exploited when you least expect them, are here in these systems that you don't think about as just utility tooling. Like, you want to think about them as the water. I just turn on the tap and my code pipeline runs. I flick the light switch and I'm saving all my source code in a repository. It doesn't happen that way. All of this is part of the domain of technical debt that you're undertaking. Your tooling hosting. So Jenkins has bugs. The operating systems on these systems have bugs. You need to worry about them. Obviously, this is motherhood and apple pie and repeating what I said before, but as infrastructure, and again, you probably shouldn't be running this stuff homegrown on yours unless for some reason it really is job 1 for you. It's got to be a priority that's not 3rd or 4th down the list. So go to somebody where that is job 1. Your development systems, again, going back to your dev laptops and your SRE laptops, phishing emails that come into those systems tend to be incredibly effective at popping infrastructure throughout your organization. I sort of ran out of time here to really try to curate a list of different interesting events that affected these things. The Cloudflare instance had a taint of this as well, so we could throw Cloudflare up in here, but I only wanted to show them in one. But various kinds of phishing emails. The Circle CI one, I think, was probably the classic example, but trust me, many organizations have had their developer laptops, their admin laptops screwed up in one way or another as people start installing, their favorite games, their favorite note-taking software. Like, all of these become ways that issues get introduced to your organization. How do you prevent this? Well, multi-factor authentication is always good throughout your organization. Endpoint protection, so installing security tools, spending money on security tools. Depending on who you are, your security budget should be relatively high. 10 to 12% of many organizations is not unreasonable. For banks, that might be higher. Some organizations may be lower. DLP is always fiddly. It does, the way that DLP is done is poorly thought out, but DLP is and seems here help you understand what's going on and can give you alerting when bad things happen on developer laptops. This one's probably bad. So your email, your identity provider, your chat provider, they've all had bugs. I really meant to look for a Slack bug here, and I kept running out of time, kept forgetting, like the squirrel, but Slack has had a number of really interesting bugs over the years that I haven't put on here. I should update them. Okta, like here's your identity provider, and yet they've had a number of really interesting incidents. You need to be on top of this. You need to be ready to react when they say react. Microsoft, of course, I'll grant that the bug that I'm listing here, the incident I'm listing here with Cozy Bear is an advanced persistent threat by some of the most stealthy people in the world. That would be the Russian SVR, which is what the KGB came under the Putin regime. But these guys are spending time to hack these people. And if you, the good news is even though they hacked like all of Microsoft Mail, they only had a few specific people that they went after. They went after the Microsoft emails that basically were the security teams that were trying to figure out what the APT crews were doing. So what they wanted to know is, what did Microsoft know about the hackers themselves? The other thing they went after was, of course, emails in the US government related to Department of Justice and what was going on with relationships with Russia. So the good news is most of us probably aren't going to be picked on by Cozy Bear. But yet, at the same time, they've got the tools to hack this. SolarWinds, like SolarWinds is the attack, basically infiltrating a monitoring software vendor. How many people here are familiar with SolarWinds? Oh, very good. Okay, so yeah. So they, again, an APT crew have pretty specific targets, but they did compromise all customers of SolarWinds. And so, you're installing this software to do network monitoring, to do systems monitoring, and it's not only doing system monitoring for you, it's doing it for somebody in some other country that you don't know about. That's bad. What can you do here? Assess the security of your vendors. And I don't care if it's Microsoft or not. Make those guys answer questions that are important to you. So find a security assessment questionnaire. There are plenty that are available for free and on the web. And there are people at Microsoft who know how to answer these things, but get it in writing that they said this so that later you have this back. Plus, for smaller vendors, make sure that they give you rational answers. Make sure those answers are in depth and you understand what they're saying. Multi-factor authentication also helps here, as it does kind of everywhere. So if you're using, for all of your third-party apps, think about what happens if they get compromised. Build a plan around it. Maybe 2 or 3 steps. Test that plan. Don't write a plan that says, step 1, hack occurs, step 2, that's figure out what you're doing. Yeah. Your browser ecosystem. This can be huge. So just the number of JavaScript bugs that come out on a regular basis, and then the bugs around essentially the plug-in interfaces that happen. So each one of these things, one of them is a sandbox escape, meaning that the the code that they dropped can see what's running on your system in the context of the current user. One allows threat actors to perform an out-of-bound memory access, which normally causes a crash, but in the right circumstances will execute arbitrary code on the target system. So, and like I say, we use this all over the place on all laptops. Keep your browser up to date. This is a treadmill. This is a treadmill set on high, but you need to figure out how you keep every laptop in your organization up to date with the latest browser exploits, because there's just stuff out there that you cannot avoid. Limit or eliminate plugins. On my personal laptops, I don't run any plugins, except my company has forced me to run an identity plugin on my laptop. So I run one. On my personal laptop, I run 0. And I know that you want to run ad blockers and so forth, and they're great for certain types of stuff. But if you're, I don't know, if you swim down the middle of the lanes, you don't have to worry about what happens on the periphery. Avoid browser monoculture. So Chrome and the Chrome descendants, which are Microsoft Edge now, which is a really nice looking browser, Chrome, but it's a monoculture. Like 90% of the browser market, I don't know what the numbers are off the top of my head, are based on the Chromium browser, and something like 85% of us run Chrome. I run Firefox. It helps a little, but if you can run Safari or some other browser, this helps with making it more difficult for the bad guys to do what they want to do. Your developers, your people in your organization are subject to subversion, and they are part of your software supply chain. So if the developers that you hire are actually North Koreans working from North Korea, chances are good that your software at the code level will be corrupt in some way or another. The nice thing about KnowBe4.com is they actually published their incident. When the FBI took down, and I had an idea for this talk in my head, and a week and a half ago, I went and our headquarters had the FBI in, and they talked about essentially what they were seeing in terms of the types of bad things, cybersecurity things they were seeing. And this whole talk changed. And this was one of the tipping points of that change, is this. But the point here is not that KnowBe4 got hacked, ended up employing a North Korean hacker. The point here is for that North Korean hacker to pull off their job, oh geez, I'm running long here, my apologies. They had to have a server farm somewhere in the US. So somebody had set up a house with a couple hundred laptops so that IT workers from North Korea could log into those laptops so it appeared that their work was coming from the US. When they rated that, so those 100 laptops represented 100 workers for enterprises throughout the US. So it wasn't these guys. These guys were the ones brave enough to talk about it. The banks of the world that had hired IT contractors, the telecommunications companies, the high-tech firms, you name it, manufacturing firms, they all were popped. Didn't talk about it. Nobody else said anything, but these guys did. This happens. Look for weird stuff that your providers do. This blog post is really interesting. Just like your North Korean IT hacker will make weird excuses. So everybody's got that time when their cat got sick and they had to stay home. It doesn't happen on a regular basis, though. You don't have a cat get sick, then a dog gets sick, then the cousin gets sick. You don't have excuses for why you can't turn on your camera. Oh, I put a security device over my camera and it's stuck and I can't turn it on. This is not normal, but they play it off as if it's normal. Or doctored pictures on the badge or in your IT in Active Directory or whatever your messaging system is. That picture looks just a little weird. Same thing can happen here. So evasive panda, cloud hacking, and yes, I'm over time, so I will shut up here. These guys built a toolkit that steals the cookies that you use to log into your cloud provider and reuses them to basically do a complete inventory of your cloud provider. So also beware of insiders and terminated employees. Thank you so much. I appreciate it. We don't have time for questions, do we?
We don't have time indeed.
Yeah.
There are plenty of questions in the chat.
Okay, I will sit down and start
Thank you.
answering those.
Thank you very much. Thank you very much, Mark.